each time a hurricane arrives, a new home has 0.4 probability of damage. The occurrences of damage in different hurricanes are independent. Calculate the mode of the number of hurricanes it takes for the home to experience damage from 2 hurricanes. Now, this reminds us of a geometric distribution. It's not geometric distribution, but it kind of reminds us of it because we're talking about the number of hurricanes it takes for the home to experience damage from 2 hurricanes. Now, remember, geometric distribution was where you need number of trials to get the first success. Now, if this was just 1 hurricane, then it was geometric distribution, but we're talking 2 hurricanes here. So this is actually negative binomial distribution. Therefore, if we let n to be the number of hurricanes it takes for 2 losses to occur, then n has negative binomial distribution, which says that the probability of needing n trials to get r successes will be given by this formula, where little p is the probability of success in each trial. So in this case, R is 2 because we are looking at 2 losses. We're trying to find number of hurricanes for 2 losses. So R is 2 and P is 0.4. That's the probability of loss in each hurricane. So that's the probability of success in each trial. So now putting this R and P in this equation, we end up getting this because this one is n minus 1, combination 1, which is just n minus 1, and the 0.4 squared is 0.16. Now we need the mode of n because we need the mode of the number of hurricanes that it takes to get 2 losses. So by mode, we mean that the value of little n, which maximizes the probability function. So the easiest way to do it is to find the first few values of the probability from this equation 1. We start with n equals 2 because you will at least need 2 hurricanes for 2 losses, since each hurricane can cause at most 1 loss. So when you substitute n equals 2, you get f of 2 equals 0.16. Now that tells us that in order to need 2 hurricanes for 2 losses, the probability of needing 2 hurricanes for 2 losses is 0.16. And similarly, this tells us that the probability of needing 3 hurricanes for 2 losses is 0.14. And then it decreases when you put n equals 4, so it increases from f of 2 is 0.16, and then f of 3 increases to 0.192, but then f of 4 decreases 0.1728. And the reason the decrease happens is that as n gets larger, this factor keeps getting smaller. And in the beginning, there was this factor, the other factors were dominating. But then when n is 3, when n is 4, this factor dominates over the others, and it shrinks now from 0.192 to 0.1728, and then it shrinks further to 0.1832. And actually, we can see the pattern that it will keep shrinking because now this has taken its dominance, and that will keep forever. Once the exponential, because this is the exponential part and the other thing is the polynomial part, whenever you have a product of a polynomial and an exponential, once the exponential dominates, now the polynomial can dominate early on, but once at a certain value the exponential takes over, then its dominance actually keeps increasing forever. And so by dominance means that whatever is having to exponential will happen to the product, and the exponential is decreasing as n increases. So from this set of values, we see that the maximum value of Fn happens at n equals 3, which is 0.192, and so the mode is 3. That was choice B.